So, hi everyone. My name is Ximing Shen. I'm here to present our project with Yoichi Kamiyama, Kota Minamizawa, and Jin Nishida. So, this is a project. This is a collaboration between Keio University in Japan and the University of Maryland. The project title is called DexteriSync, and in this project, we design a hand thermal IO exoskeleton to deliver dynamic temperature changes to the finger skin so as to change people's hand performance. So our hand is the primary media we use to interact with the surrounding environment because it can provide fine hand interactions, tactile feedback, and also multi-touch capabilities. And among these, Dexterity is actually a major function that allows us to perform everyday fine tasks, such as typing, writing, buttoning our shirts, and also grasping objects, etc. And meanwhile, last is known about what is compromised dexterity. So compromised dexterity actually happens to a large number of the population, such as older adults or people with neurological disorders or some neurodivergent individuals. And there were very few works actually look into techniques to decrease people's hand dexterity. And most of them use gloves or physical restrictions that can restrain the finger moving range. And a lot of these tools were used to replicate everyday challenges faced by those people who have this kind of compromised dexterity issues, which is supposedly to help designers to make more accessible product designs. However, as you can see, most of these tools, they do not capture the full experience of having compromised dexterity, and they have limited adjustability, which restricts the range of conditions and scenarios that they can represent. And meanwhile, do you know that temperature is actually a key variable that can influence our hand dexterity by altering sensory perception, blood flow, and also muscle contractions? And therefore, actually, skin temperature has a strong impact on humans' physical performance. So for example, we know that in cold environments, people who work outdoor, their hand performance is sometimes decreased, and also in extreme temperatures, athletes' performances can be also influenced, such as playing outdoor tennis in extremely hot weathers. So leveraging this feature of temperature, in this paper we developed a hand thermal IO exoskeleton, which we call DexteriSync, to provide a further realistic and computationally adjustable experience of having this kind of compromised dexterity issues. And we went for a hybrid cooling methods, combining material conduction and water convection for this. So the exoskeleton itself has three different parts. It has a 3D printed palm base. It has 3D printed finger sockets and also silicone and copper tube segments. And this is a close-up image of all of the three parts that we created. So the idea is that we attach coppers to where we want to deliver temperature changes for its robust heat conductivity, and everywhere else we use silicone tools for the flexibility. So and this is the overall configuration of our implementation. So besides the exoskeleton wearable parts, it has a water storage unit with pump system and also the temperature PID controller. And then in a series of user studies, we evaluated our DexteriSync exoskeleton. So in the first user study, we evaluated the dexterity changes by asking the participants to conduct a pegboard test, which is a standardized fine motor skill assessment method. So participants were asked to put 10 pegs into the board each time following pre-designed patterns. And so the results is that we found that at both the the point of 5 minutes and 15 minutes of cooling, the participants' performances were significantly lower than the baseline where they wear the exoskeleton but with no temperature changes applied. We found that in general, the pegboard performances showed a decrease, increase, and decrease pattern. So this suggests a homeostasis influence, which is our human body's ability to maintain a relatively stable internal state that persists despite the impact in the outside world. And then we also inquired about participants' subjective experience of the pegboard test. So participants' perceived agency dropped drastically at the beginning, but then gradually increased back. So we believe that this false sense of agency might be because the participants were getting used to the temperature, which led them to believe that they had more control of what they were doing, but they actually were not performing well as they thought. And then we also inquire about their body ownership, which we found that their sense of body ownership is actually a more effective indicator of their actual performance. And secondly, we also study about their thermal perception. So in this study, we actually applied different temperatures to each finger. So we found a significant value in doing this because this kind of imbalanced or unpleasant thermal sensations is quite commonly experienced by the hand disordered populations. So this study focused more on simulating the sensory experience rather than the physical experience, and we believe that this sensory simulation is important for understanding their experience with in the real world. And so in this user study, we used 2 different cups for each hand, and we continuously changed the water temperature inside the cups. And then we stopped when the participants identifying that the 2 cups are feeling the same temperature. And the result actually shows that, so when the participants believe that the temperatures were the same, on average, the real temperature on the DexteriSync hand water temperature is lower than the bare hand. So this means that their hands that wears the exoskeleton will overestimate the temperature higher than it is. So we believe that this overestimation of the temperature was caused by this combination of imbalanced temperatures, and this would suggest the occurrence of the thermal grill illusion, which is a thermal phenomenon. And lastly, we also used our prototype in a more practical setting where we explore how this kind of compromised dexterity experience can support product design process. Yeah. So we recruited 8 design students and split them into a video exoskeleton group and also a video only group. We then asked the students to design assistive tools for daily necessaries, and we asked them to sketch about these experiences, these designs. We then also inquire about their experience about this whole design tasks, and we found that DexteriSync designers were generally more confident in their own design and believed that the problem were more demonstrated realistically. So some of the key takeaway message, the findings we had from these research is that we found that although participants' dexterity were influenced by the temperatures, it is quite common that they would reach a homeostasis because of our thermal regulation system. And also, in our second and third studies, from the qualitative feedbacks, we found that when the thermal grill illusion happens, some of the participants will report that their hand coordination were changed by the phenomenon. So we believe that it is possible to introduce this kind of thermal perceptual illusions to further influence their hand dexterity. And then lastly, we also believe that experiencing this kind of embodied compromised dexterity can have the potential to support more efficient and also user-friendly assistive tool design. That's it for my presentation, so thank you guys for listening.
Any question? Feel free to come to the center.
Hello, my name is Yotam from the University of Tokyo. Thank you for the very interesting presentation. In very, very extreme temperatures, the body might release adrenaline, which might affect performance and dexterity of people. Is this something that you looked at or examined?
I'm sorry, I didn't hear you clearly.
So in very extreme temperatures, for example, very cold temperatures, the body might release adrenaline, right? Which might affect or not performance and dexterity. Is this something that you've considered?
We thought about this, and we believe that it is like for this kind of extreme condition, rather than something we try to achieve, we would like try not to go that far when we were designing the whole experience. Yeah, which is why we purposely limited the amount of time for participants to use this device, because although there's a very huge individual difference in like skin temperatures, we do found that some participants' skin temperature kept on decreasing and decreasing and decreasing, and because I think there is a threshold for like safe skin temperature. So when it goes down too low, we just suspended the experiment. Yeah.
Thank you so much.
Yeah.
Any other question? I do have a question. So I feel like temperature can change a lot of how we behave, even beside like dexterity. For example, I'm like in a cold room and I might feel like different emotional state and mental state. Have you considered like other effects that might be affected by temperature?
Like what type of performance? Sorry.
Like people tend to feel more stress like in the colder environments, and do you consider explore those in the future?
If we can pass the IRB for it, then probably, yeah. Yeah, I think that is an interesting direction to go with, and it is somehow reflected in our subjective assessment of like sense of agency and body ownership a little bit. So we do believe that when they feel like a bit like too freezed by the experience, they're like this kind, like they started to have more like a little bit stress and negative thoughts about it. Yeah.
Thank you. Okay, let's thank the speaker.